What's up, everyone? This is LeetCode 75, sort colors. We've done this problem in Python. Now we're going to do it in C++. So we are given an array nums with n objects colored red, white, and blue. We have to sort them in place so that the colors are adjacent to each other. Now, don't get confused by the word colors. Honestly, the simpler way to view this problem is just look at the input, right? We're just giving integers, right? 0, 1, and 2, and we have to sort them so that they're in ascending order, okay? And we can't use a sort function. So it's basically just a sorting problem, but it's a little bit complicated because we have 3 numbers instead of 2. And we have to do it in one pass with only constant extra space. Okay, so there's 2 solutions to this problem. There's an inefficient solution, which I'll show you, and then I'll show you the more efficient solution. If you get this problem in an interview, I think they're going to want the more efficient solution because it's very specific to this problem. We'll go over that second, though. So really, the way you want to approach this, at least inefficiently, is you can do 2 passes where basically you're going to go through this array, right? The input array, and you're going to count the frequency of the 0s, the 1s, and the 2s. And then on the second pass, you should know basically how many 0s should come first, right? Like, are the first 3 numbers supposed to be 0s, or is it the first 2, right? And you just modify the array that way, okay? So that's how we're going to do it. It's actually really simple. It's just just not that efficient, right? So we're gonna have a counter for every single one. You can use a hash map, whatever you want to do, doesn't really matter, right? But we're just gonna do it this way. Okay, so we're gonna say I is less dot size. The reason I show this is because it's inefficient, but I think it's still. If you can't remember the efficient solution, this one will still work. As long as your interviewer doesn't care. If you use the specific algorithm to this problem. Anyways, we're gonna go through this the first pass, right? If we have a 0, let's increment the 0 counter. So plus 1. We're gonna say else if nums of I is 1, 1, 1, right? Else. Sorry, this is not Python. This is C++. I forget. Else, we're gonna increment the 2. Okay, so that's our first pass. And our second pass is basically going to go through the array again, right? We're going to go through the array again in the second pass, and we're going to use the variables to basically modify our array. Okay, so we're going to basically say if the counter for 0 is greater than 0, then we can just do nums of I, replace that with a 0, decrement this counter, right? Else if 1 is greater than 0, we can say nums of I is equal to 1, and then we can say 1, and then else, that's where the 2's come in. I don't know if I made a syntax mistake or not. We'll find out just now. Oh, it looks like it's all good. Okay, so that's kind of the inefficient approach. It's really simple, but that's not the point of this problem. The point of this problem is the efficient solution, which is uses a very specific algorithm called the Dutch national flag algorithm. And it's very specific to this problem because the Dutch national flag also has red, white, and blue, right? And you can kind of see how they relate. It's a specific problem, right? It's called the Dutch national flag problem. It's basically this problem, except called sort colors on here, right? And really, the gist of the approach for this algorithm is like, well, when you look at this problem, you might think, okay, can I use 2 pointers to solve this? And you would be somewhat on the right track, but the problem with 2 pointers is that there are edge cases where your algorithm or your approach is going to fail, right? And so you actually have to use 3 pointers, and that's kind of what the gist of this algorithm is. And basically, you're going to have a left pointer that's going to be on the left side, and it's going to basically it's going to basically keep all the 0s on the left side. The right pointer on the right side of the array is going to keep all the 2s on the right side, kind of like a 2-pointer approach. And then we're going to have a third pointer, which is going to start on the left side initially. We're going to call it I, and it'll move forward, and it'll help us keep the 1s in the middle, but also help us with kind of the swapping, okay? So let's get into this, right? So let's set up our pointers. Int L is equal to 0. Set the right at the right pointer at the very end. size -1. And again, the I pointer is initially at the start. Okay. So we're gonna say while the I is less than or equal to R, because once the I passes the R, we know we've done everything we can to sort, so we can just exit, right? Now there's a few cases we have to handle, okay? So let's say nums of I is, so if nums of I is equal to 0, we have to basically put that 0 on the left side. So that's kind of the point of the left pointer, right? So we're gonna say int temp, say nums of L, and we have to use temp variables because this is C++. In Python, you would just do this all on one line, but fine. Nums of R is equal to nums of I. Or sorry, not nums of R. I don't know what I'm doing. I mean nums of L. Sorry. Nums of L is equal to nums of I, and then nums of I is equal to temp. And then, so we did the swapping, right? When I is 0, because I starts where at the same place as L initially, but I can move forward, right? And if I moves forward and we encounter 0 somewhere else, we have to basically swap that number with whatever the left pointer is, because we want to, when we encounter a 0 wherever I is, we want to put that 0 on the left side, right? That's kind of why we're doing the swapping. And when we do the swapping, we move the left pointer forward. And then outside of this, we move the I forward. And I'll kind of explain that in a little bit. There's also another case, right? Which is if nums of I is equal to 2, we basically want to do the same thing, okay? I'm just going to copy this because it's really, we're doing the swapping again, except we're going to do it to the right side, right? So, let's do right, except right here we want to do this, okay? So when I is moving forward, if we encounter a 2, we want to move that to the right side, right? Because that's the point of the right pointer. So we want to do a swap, and we want to move the right pointer back, right? Except we also want to move the I back. Okay? And this is where I'm going to explain the side down here. So when we move the left pointer forward, we want to move I forward, right? But why don't I include the I here? Why do I put it down here? Because if there's a case where nums of I is equal to 1, we want to move forward as well. We don't want to do anything. And so that's kind of, this kind of handles those two cases, the 0 and the 1. Because we want to move I forward. Because when nums of I is 1, we don't want to do anything. There's no swapping, right? Because we want to keep the 1s in the middle. Except when nums of I is 2, we want to swap, but we want to move I backwards so that I stays in the same place, right? Because if we go backwards in I, well, down here we go forward, right? And so this kind of, this I minus 1 is basically to undo this so that we stay in the same place, right? And the reason we have to do that is because there might be a case where we swap a 0 from the right side to the middle, and we don't want to move I forward because it's possible we want to move that 0 in the middle to the left also, right? That's really the important part, right? And I'm going to give you an example. We're going to go through an example really quickly just to show you exactly what I mean, and it'll make 100% more sense. So let's say we have something like 0, 1, 0. Okay. And I'm going to set my pointers up. Left. And again, initially in this algorithm, the I starts at the 0th index also. Okay. So let's run through this algorithm, right? So nums of I, is that equal to 0? Yes. So we're going to do the swapping, right? So basically it's swap with itself because they're both on the same place. So it doesn't matter. So the L moves forward. Nice. And then down here, the I moves forward as well. Okay. Now, is nums of I equal to 0, equal to 0 or 2? No, it's equal to 1, right? So we don't enter any of these. We just move the I forward again. Because again, the 1s are supposed to be in the middle, right? And now we have this. We're going to enter here. Now, imagine this isn't here, right? Imagine we don't include this. What would happen is we would swap this 2 and this, we'd swap this, this 0 with this 2, right? So this would be 2 and this would be 0. What would happen is I would move forward and R would move backwards, and we would exit this program, right? Because this while statement would not be true anymore. except our input is not sorted, right? We have a problem, right? And so this right here is to handle that edge case, right? Because when we do this, when we enter this else if statement, right, we're gonna do the swapping here, 0, 2, and we're gonna do and then we're gonna do r minus 1, right? And that's I minus 1, and then we exit the else if and we do I plus 1 again, and it's in the same place now, right? It didn't move forward. Now, why is that important? Because now this 0 we can move, right? Because we for the next step we check, okay, is nums of I equal to 0? It is. So why don't we swap this with the left pointer, right? So we do this, we do this. I moves forward. The L and the R would be at the same place. I just can't really show that through text, but you get the point. And now we can exit the program, right? Because this would be not true anymore. But now we actually sorted it properly, right? And so we have edge cases where we need this. Okay, I hope that makes sense now. And I believe this should work except for my semicolon that is missing. But yeah, that is the Dutch national flag algorithm. I don't know, I wouldn't say it's necessarily easy to come up with on your own, but I don't think it's too difficult to understand. But it's submitted right. I just didn't run it. That's why it says compile error, but it works. But yeah, not the easiest algorithm to come up with on your own. It's a little bit obscure, honestly. But it's not too hard to understand. So I honestly just learn it and keep it in your back pocket. If you get this problem in an interview, you should be able to ace it because this algorithm isn't too hard to come up with on. Or it's not too hard to come up with on your own in an interview if you've seen it before. It's basically just a 3-pointer approach, really. I mean, and you're also handling certain edge cases. That's about it. It's just don't overcomplicate it. But I hope my explanation made sense. And yeah, I'll see you in the next one. Peace out.